Here is my supply of distilled water, which we are about to split into its constituent gases, hydrogen and oxygen, and for that I need a little tool, and this is it. This is an electrolyzer, which quite simply consists of two little tubs of water separated by a membrane, which has the almost magical quality, some would say this is simple electrochemistry, to separate the gases whilst in the water and keep them separate so they can be used separately. So now we're going to fill up the two little columns here, without spilling too much, we hope. There we are. A little bit of spill doesn't matter, it has to be absolutely full. Put this back on here so we don't waste anything in good lab practice. Put the tops back on here so as to fill the space completely. We don't want any air in there, but we don't nitrogen or oxygen getting into these two containers. Then we turn it upside down and we're ready to begin. The first thing to do is to show that with a wind turbine, and this is my minor little wind turbine, generating electric current, which of course is DC, not AC. You can't electrolyze water with alternating current. Obviously it has to be direct current. So to make it nice and easy for people like me, red to red, black to black. And now if you're patient, I am going to start turning my wind turbine in such a way you're going to see quite soon some bubbles coming up. And you're going to see signs of gas being produced in those water columns in two proportions, twice as much on one side as on the other, which reflects the nature of water, hydrogen and oxygen, H2O. I'll make a little bit more of this stuff. Obviously this is only 20 or 30 watts, my poor old muscle power going in. If this is a wind turbine with 5 or 6, 7 or even 8,000 kilowatts, you will get gigantic quantities of hydrogen. Hydrogen, of course, being important, that once you have hydrogen you have a fuel which, when being burnt, doesn't produce carbon dioxide. It only produces dihydrogen oxide, which, as you know, is simply water. Now we stop for a minute. And what we're going to do is we're going to attach the wind turbine to something which is a witness to the power of electricity. And this is our witness. This is a little motor here which we're going to power by the wind turbine. And there's a big lesson to come off here. I wonder if the camera can catch that. The wind stops, this doesn't turn. The wind goes and it turns. This, of course, is only 60 centimetres from there to there. In a big industrial installation it can be many kilometres and work very well. This will be the equivalent of the grid which supplies all of us. The big lesson, of course, is that the wheel turns as a witness to electricity going through only when the wind is blowing, when the wind turbine is turning. Now let us see if we've been able to store some energy, perhaps in a chemical form. Now we have to be a little bit more careful and we have to complicate our wiring a little bit. Another black and another red. Now let's see what happens. Red to red again. Red to the witness. Black to black again. Black to the witness. No wind and it's turning. I wonder why that is. It is because this little machine here functions both as an electrolyzer, it is sensitive to electricity and it splits water, but it is also sensitive to the hydrogen and oxygen which is produced and unites them again in order to create electricity which you want. In that case it's a fuel cell. It is what we call a reversible fuel cell, and it can do both at the same time. Here's the wind turbine and it's doing both. It's turning the witness wheel and it is also producing hydrogen. Now the wind stops, the witness keeps on turning, and there the hydrogen and the oxygen are combining across this membrane in the middle in order to generate electricity which we want. And if I touch that with my finger, I can actually feel the strength of that being turned simply by two gases uniting and creating electricity.